Welcome. Today we're going to talk about more complicated integrals. And when I say more complicated integrals, really we're going to talk about inverse trig. So I'll give you the formulas, we'll talk about examples. Seems like not much, but these are actually messy, so they take a while. So, inverse trig integrals. The integral of 1 over square root of 1 minus x squared would be the inverse sine. The integral of 1 over 1 plus x squared dx would be the inverse tangent of x. And the integral of 1 over x times the square root of x squared minus 1 is the inverse secant. Now, notice there's absolute values here. Technically that's supposed to be there, but we don't usually worry about it. Actually, if you notice though, there are several missing. There should be like 6 of them, and we only have 3 of them, because most of the others are related. For example, the inverse cosine has a derivative with a minus sign here. That's all the difference it has. So if you find a minus sign there, well, you could use the inverse cosine, but instead you can just bring the minus sign out and get minus the inverse sine. They are equivalent, especially with this plus c here, but let's not dwell on it. These are the only 3 you really have to remember. Let's try some. Now, you might have thought, oh yay, that's all there is. But notice these, they're not exactly like those other forms. So we have to figure out what to do with these extra bits. They're going to be u substitutions. And all you have to do now is figure out how to do them. So I'll let you have a couple seconds, figure it out, put a pause, come back. Hopefully you made some headway. But let's see. This first one, we want to make it look like one of the forms. So which form does it match? It matches this one. It's going to be an inverse sine. I need a 1 minus x squared here. I can't have something else. I need a 1 minus, that's not an x. That's not an x squared. So we can't do this with 1 minus x squared. So that better be something we substitute out. But it's not x. We're going to do a u substitution, but that is not our u. Because we don't want a u there, we want the squared. So our substitution is going to be u squared equals 4x squared. Because that'll make it look right. Hopefully. It might not turn out right. You got to always have your du around. But let's try it out. If that's the case, what does that mean? That means u is 2x. Could be plus or minus. We can pick whichever one we want. Does that work? Well, we still need the du. So what's du? 2 dx. That we can work with. Do we have the 2 dx? We've got the dx. We don't have the 2. But we can get a 2. So let's do that. We do it this way, right? Multiply by 2 over 2, because that gives us the 2 we want, which is on top. The dx of the 2 here is our du. That's our u squared. So this is the integral of 1/2 1 times 1 over square root of 1 minus u squared du. Pull the 1/2 out. We have 1 over square root of 1 minus u squared du. That's the inverse sine. So this is 1/2 the inverse sine u plus c. We're almost done, but since we didn't start with u's, we better not end with them. We better end in our x's. This is going to be 1/2 the inverse sine of 2x plus c. Notice if we had, for some reason, done it with minus 2x, we'd have had a minus sign, the minus would have been here and here, and because the sign is odd and its inverse is therefore odd, it would have popped out and come out the same answer. This next one is, well, the x is fine. We wanted a, what is this like? This one is like this, 1 plus x squared. The x squared is fine, but the 9 isn't. We need a 1 there. It really can't work. It just simply can't without 9 there. So we've got to figure out what to do. I can just pull 8 of them out. But that doesn't work either. So, what I'm going to do, it's a trick. All of these are really kind of tricks. Things to do with all of the form so that you can get it into the form you need. And what I really want is a 1 there, so I'm going to factor 1/9 out. Because if I factor the 1/9 out, I have 1 plus, right? But then this is 1/9 x squared. So I pull the 1/9 out, that'll be great. This now, unfortunately, because I have to factor the 9 out, that's no longer x squared. I'm going to have to do the same thing I kind of did here, except now it's with an inverse tangent. So let's walk through this one again. This one, u is going to, well, u squared is 1/9 x squared. So u is going to be 1/3 of x. So du is going to be 1/3 du. I'm going to pull the 1/9 out. I need a 1/3 up here. So 1/3 of here, 1/3 of here. So actually, let me wait on pulling the 1/9 out. So I've got a 1/9. I need a 1/3 over 1/3. I would not normally write it that way. But I want a 1/3 for my fraction. I want 1/3 du. I'm sorry, dx here. So this is my du. The bottom, notice these two multiply together. I get 1/3 times 1 over 1 plus u squared du. The 1/3 comes out. I have an inverse tangent. And then finally I get 1/3 inverse tangent of, what was that? U again. U is 1/3 x. Our rate is x over 3. Notice these take up a lot of space, a lot of calculations. They're messy. These are messy problems. One more. This one's going to be messy too, but hopefully you have an idea what to do. I'll give you some time to just kind of get messed up with it. Okay, so we want, this part's good. We want this form. The absolute value of x, square root of x squared minus 1. So coming back, remember the absolute value, we don't care so much. That's not there, but who cares? This should be x squared minus 1. So both the 3 and the 8 are foreigners. We want that to be gone, and that would just be a 1. The 8 is actually the harder one to deal with, so we'll deal with that one first. So I'm going to factor it out. Just like I did before, I'm going to factor that number out, so I'll have a 1 there. So I'll have integral, 1 over, I'm going to leave that for a second, but we'll have 1 over x times square root of, if I pull the 8 out, I'll have 3/8 x squared dx minus 1. So I've pulled 8 out of that, because if I multiply by 8, I have the same thing. So I pulled the square root of 8 out of there. Notice that's a square root because of what's going on. So that's a little trickier. This one is, okay, not a little, this one's a lot trickier because there's more things going on than those two. But we can still work it out. We now need this to be our u squared. So u is going to be square root of 3/8 times x. So that means du is the square root of 3/8 dx. So I need a square root of 3/8 on top and bottom. So this is the integral of square root of 3/8 over square root of 3/8. See, it's not pretty, but we're getting somewhere on this. Times 1 over square root of 8, that was still there. Times, what else do we have over here? 1 over x. Well, actually, x is going to be a trick, so I'm going to, well, I'll leave the x for a second. This is square root of, that's a u squared minus 1, just in preparation. Now, this dx and this, that's our du. That's great, but I still have an x here. What do I do with that x? I need to turn the x back into a u somehow. And notice, very conveniently, x times this is u. Doesn't always work that way, and sometimes you have to solve for x on some of these. But what do I get? I get that part's being absorbed. That part's being absorbed. So I have 1 over square root of 8 times 1 over u squared of u squared minus 1 du. And all of that is the inverse secant. So I get 1 over square root of 8 inverse secant of u. So then rewriting it in terms of x, 1 over square root of 8 inverse secant of square root of 3/8 x plus c. Don't forget the plus c for an indefinite integral. All of these apply just as well for definite integrals. If you got like from 1 to 6, you would then plug 1 and 6 in. Or you could have switched out, you could have gone all the way through, converted all of the limits to u limits, and then not have to go back. However you do it, these are messy, but they're doable. Until next time, this is Dr. Joe.